All right, guys, Mr. Antonucci here, and we're in section 9B, significance test for the slope of a population regression line. In this first video here, we're going to talk about how to state the appropriate hypothesis and check conditions for a test about the slope of a population regression line. Now, when we have two quantitative variables, we typically express their relationship using the slope of the population least squares regression line. So if there's no linear association between x and y, the population slope would be zero. So our null hypothesis is typically going to be that beta equals zero, meaning linear regression is no better at predicting y than simply using the mean of y. But suppose we wanted to see if sitting closer to the front of a class improves test scores. So we're going to look at a little example here. Specifically, we examined whether smaller row numbers were associated with higher test scores, so a negative association. In other words, the closer you sit, the higher your test scores. So the hypothesis for these tests would be the null is there is no linear association between row number and test score. Remember, the null hypothesis is the dull hypothesis. The alternative would be there is a negative linear association between row number and test score. In this case, it would be a negative linear association as opposed to a positive or some association because of the direction indicated by the context of the problem. Symbolically, we could write the null and alternative like this. The null is b equals zero or beta equals zero, and the alternative beta is less than zero. And then we need to also make sure we're defining our parameter, where beta is the slope of the true least squares regression line relating y equals test scores to x equals row number. So we've defined in context what beta represents. It's the slope of the true least squares regression line relating x and y, but x and y in context of the problem we're solving. So that's how we set up the appropriate hypotheses. Now we want to talk about how to check the conditions. Now the conditions are going to be the same as they were for constructing a confidence interval for the slope beta. So linear, normal, equal SD, random, and 10% condition if you're sampling without replacement. Remember your acronym LINER1, LINER 1 for that. So on the AP exam, sometimes for the free response questions, you're told to assume the conditions for inference are met. Not all the time, so read the question carefully. But if that's the case, don't waste time checking the conditions. You don't earn any credit for doing so if they told you to assume that the conditions are met. And you might actually lose some credit if you say something that is incorrect in that portion there. So let's look at an example here. Are students with longer feet typically taller than their classmates with shorter feet? So 15 high school students were selected at random and asked to measure their foot length and height in both centimeters. And below we have the computer output from a least squares regression analysis of the data. So if we want to state the appropriate hypothesis for a test about the slope of the regression model for predicting height from foot length in the population of high school students, here's how we would do it. The null is beta equals zero, meaning there is no association, um, or and the alternative is beta is greater than zero. Again, here this would be greater because in the context of the problem, we're saying that we are trying to see if students with longer feet are high or are taller, essentially. Also, we've defined the parameter where beta is the slope of the population regression line relating y equals height in centimeters to x equal foot length in centimeters for high school students. So make sure you define what x and y are in the context of the problem, include their units if that's appropriate, and the overall population as well here. In this case, it would be for high school students, not just any person. So we can also look at why the data provides some evidence for the alternative. Now, we haven't shown that it's convincing evidence, but there is some evidence for the alternative because from the computer output least squares regression analysis, beta is greater. We do have some evidence because B, the slope for foot length, is 2.7469, which is greater than 0. Now, we want to know, is the random condition met in this case? Yes, because the 15 high school students were selected at random. All right. So guys, that's it for this one. Hope that was helpful to you. Reach out if you have any questions.